everyone. Welcome to today's event. This public lecture is the eighth public lecture organized by Electrical, Electronic, Telecommunication Engineering Sectional Committee. So today's topic is telecommunications as critical infrastructure for disaster management. Actually, this is a very timely needed topic because we experienced several concerns during Ditwah cyclone as well. So our resource person is Dr. Himal A. Suraweera. He's a senior lecturer from University of Peradeniya. So without taking much time, I would like to invite our chairperson, Engineer Viraj Muthugala, to welcome our resource person and also the audience to this event. Thank you.
All right. Thank you, Dishanta, and good evening, everyone. So it is my pleasure as the chairman of Electrical, Electronics and Telecommunication Engineering Sectional Committee of ISL to welcome you all for today's webinar on telecommunications as critical infrastructure for disaster management. So within today's session, we will be covering several important areas, including the role of telecommunications as the backbone of disaster management, and early warning and emergency response systems, and the impact of events like Ditwah cyclone in Sri Lanka, Sri Lanka's telecommunication infrastructure. So we will also look into advanced technologies such as artificial intelligence in strengthening communication systems and supporting post-disaster recovery. So we are honored to have Dr. Himal Suraweera today with us as the resource person. He's a senior lecturer at the University of Peradeniya and holds a PhD from Monash University. His expertise in advanced wireless communications, including 5G, 6G, and emerging technologies, definitely make him highly qualified to speak on this subject today. So I would like to thank all the participants for joining us today with us, and also I would like to encourage you all to actively engage in this session. So wishing you a very insightful and a productive webinar today. Thank you. Over to you, Dr. Himal.
Thank you very much, Viraj, for the kind introduction about myself. And first of all, I would like to mention to the participants that I'm suffering from a sore throat, so my voice has a little bit changed. And I apologize you for the inconvenience. Hopefully, I will be understandable to you, all of you. I'll do my very best. Basically, as Viraj, and also I would like to thank Dushanta for inviting me to deliver this presentation. Basically, the title of my today's presentation is on telecommunications as a critical infrastructure for disaster management. And I think all of we have a good, vivid memory of Cyclone Ditwah, which ravaged Sri Lanka at the end of November. And I think we all have a lot of personal experience with the cyclone and the catastrophe. So basically, and one of the main things during the cyclone was the damage to the telecommunications infrastructure. And as a result, a lot of people could not communicate with their relatives as well as authorities effectively. And that caused significant amount of problems in the country. So what I will do today is just to introduce telecommunications as a critical infrastructure to enable disaster, for example, early warning systems, as well as how to manage the disaster effectively in future disasters, in the case of future disasters, as well as to recover from any natural disasters that will occur. Hopefully not, but occur in future. My name is Dr. Himal Suraweera, and I'm from Department of Electrical and Electronic Engineering at University of Peradeniya, and my specialty is on telecommunications engineering. With that, I will move on to the first slide of my presentation. Hopefully you all now see my first slide. So this is just an overview. So I will quickly recap or refresh your minds with the impact of Cyclone Ditwah, which happened last year. And also then I discuss about the role of telecommunication systems in disaster response. I will talk about, like, say, how telecommunication systems can be designed to, for example, perform uh, early warnings, and then during a disaster, how to, manage various actions related to the disaster recovery, and also, like, say, in future, like, say, how our telecommunication systems can be strengthened so that in the case of a future disaster, we will be in a better position to address those issues. And then finally, I will also talk about the role of AI, or artificial intelligence, as a transformative tool that will, I think all of you are familiar with AI as a tool that will enable uh, as a proactive solution. In this case, I will discuss about early warning as well as how to do resilient recovery using AI techniques. So this is just a basic introduction to what happened during Cyclone Ditwah. Cyclone Ditwah made landfall in Sri Lanka in late November 2025, and then it brought intense rainfall and as well as widespread flooding. And then as a result of flooding, I think many parts of, especially the central regions as well as eastern regions of the country, experienced severe landslides in multiple locations as well as areas. So it became one of the most severe natural disasters in recent decades. And as I mentioned, primarily it affected the central part of the country and eastern part, but I think by and large, all 25 districts across the country were affected, and hundreds of lives. We lost hundreds of lives, as well as many people reported still missing, and tens of thousands were displaced into temporary shelters. And with that, critical infrastructure, including roads, bridges, power systems, water systems, everything, like even housing, suffered extensive damage. And I got this number from internet. It says that over about 2 million people were affected, but these numbers can even be larger. So basically, there was a lot of humanitarian aspect related to this kind of a disaster. Basically, emergency shelters were constructed quickly to house over, it says, 220,000 displaced people, and healthcare systems were damaged, leading to increased risk of waterborne diseases and limited emergency care. And also, like, say, access to clean water as well as sanitation was disrupted. And then also economically, due to the disruption to local markets, supply chains were affected, and that caused at least temporarily food shortages and fuel shortages as well. So, with the destruction of the power of the hurricane, the impact of the humanitarian impact was significantly higher. So, then there are critical challenges. So we identified during Cyclone Ditwah. So this is one of the main motivations for my today's presentation. So, excuse me. So, widespread telecommunication and power outages disrupted early warning and emergency alerts, leaving many communities unaware of the danger. So, I think now my memory is also fading, but I remember in January and February period exactly what happened during those, I think, 5 or 6 days. So basically, I think we lost power. And then in my home area, I think it was lost for about 3 days. And then as a result, the telecommunication networks were not functioning. And then basically nobody was able to communicate with each other. and also had limited access to real-time weather and flood information for, let's say, the responders as well as to the public. So because of the lack of power, there was no way of connecting to the internet. And then as a result, this information was not available to many of us. And interagency coordination, that means between, let's say, institutions within the country was significantly affected or slowed down by the damaged infrastructure. And as a result, that impacted heavily on the relief distribution as well as rescue operations to to maybe rescue affected people. And also, there were a lot of roads flooded, landslides, and disrupted transportation. And the delivery of essentials as well as medical aid were to do these kind of things were challenging. So basically, I can now, as you all now see, there was a significant impact with the cyclone experience. So this prompted us to look into, say, the role of telecommunications as a critical service, and then also to learn what went wrong with the telecommunication networks. And also, as I mentioned, there are a lot of new technology related to this kind of that you can deploy in the case of natural disasters. So today I will be discussing some of those things with you. Telecommunication systems as a critical infrastructure. So basically, telecommunication supports early warning and disaster response by enabling timely alerts. So this is just one service. But I think if you take a disaster, there are different phases of the disaster. So one is the early warning period, then the disaster, the unfolding period, and then we need to respond to the disaster, both to assess the property damage as well as damages to humans. And then also, we have to plan for future in the case of disaster recovery. So in all four of these critical periods, telecommunication services are vital. So it coordinates government agencies. So that means telecommunications is an enabler to coordinate government agencies and also emergency services like police and the military for improving effectiveness of rescue as well as relief operations. And also, for normal citizens or people, telecommunications provides access. It provides access to accurate information. Basically, during the disaster, people are well aware of what's happening in the environment, as well as what type of protection that they should they should get to save their lives and so on. And also, it supports data collection for future planning, as well as to monitor the situation. And then, as a result, the authorities can do precise damage assessment for various tasks. So, from now onwards, I will discuss various kind of technologies or techniques that are useful, not necessarily this time with Ditwah, but at least in the any future natural disaster, we can deploy these kind of technologies. So I think all of you know that say now there's a significant growth in the use of mobile phones. So digital growth is significant, and in some cases, some people have even more than one mobile phone using. So as a result, there are a lot of services that we can deploy to do early warnings. So basically, we can develop applications or apps, mobile apps, to alert citizens. For example, location-based SMS, as well as mobile apps, as well as social media, and internet alerts, as well as you can do notifications using Wi-Fi. So these kind of notifications are helpful to disseminate knowledge or information to risk populations, minimizing the casualties as well as property damage. And also these things support timely evacuations because sometimes when you have a flood situation, it can change significantly within a very short time. So these kind of alert systems are helpful to do timely evacuations from their property to a safe place, perhaps like a location in high ground or a community building and so on. So also, like say, these kind of alerts are helpful for real-time hazard updates, safety instructions. So some people, like say, when they are alone at home, they would be scared of the situation. So they could be personally even guided using these kind of alerts and instructions. So the next thing is, so these kind of alerts not only are limited to these kind of devices, so you can also use internet to disseminate alerts. So they provide real-time updates about the flood, landslide, cyclone, storm conditions, and so on. And now, due to the popularity of social media, we can rapidly spread these kind of official warnings to a wider audience, and also to help this information will, like say, I mean, since people these days have issues related to trusting information. So basically, we can provide some kind of verified guidance to, let's say, stop misinformation as well as disinformation spreading through these kind of alert services. So it's and also uh, basically these kind of services allow people to access interactive maps, shelter locations, right, when they want to evacuate, and also safety instructions for better readiness in the case of a natural disaster. So, I mean, now there are different forms of warning systems we can implement. I'm not so sure whether we had these kind of warning systems or in an organized manner during Cyclone Ditwah. So even Wi-Fi things, Wi-Fi systems can be used for public warning as public warning systems. So these kind of systems broadcast emergency alerts in public spaces, say for example in shelters, in schools, as well as government buildings where people go to protect themselves. So also it ensures safety information for people where mobile coverage is limited. So because like say in a shelter or in a building, a Wi-Fi network can be quickly set up to disseminate this kind of information to the citizens. So as I mentioned in earlier slides, the information can be of many different types. It may include updates on hazardous events, evacuation routes, as well as the availability of shelters. Because sometimes when you go to one location, maybe it is overcrowded. So as well as you might have to leave to another shelter that might be better suited for you. So these kind of things can be done with this kind of Wi-Fi based public warning systems. So now if you talk about early warning systems, now IoT technology has matured a lot these days. So basically we can deploy sensors as well as IoT devices to, for example, this is before a natural disaster, to assess the ground conditions and also to predict about, like say, these kind of disasters that might happen in future. I think in countries like Japan, where natural disasters are pretty common, these kind of sensor networks have been widely deployed, not now, but from a long time ago. So as well as there could be other countries which are using this kind of technology. So anyway, In future, we can design sensors as well as IoT devices to monitor rainfall, river level, soil moisture, as well as the health conditions of critical infrastructure in real time. So basically, these kind of networks provide data-driven support for early evacuation decisions, as well as they enhance the situational awareness for authorities, enabling rapid response and integrates, let's say, these systems can be integrated with the communication networks to trigger alerts and inform the public of upcoming or imminent natural disasters. So basically, there are a lot of established IoT communication technologies. For example, narrowband IoT, LoRa networks, as well as Zigbee networks. And these kind of technologies enable reliable, low power sensor connectivity. So one issue with these kind of technologies is the power, because I think they have to be powered using batteries, or like say, since access to mains electricity will be very difficult in the case of a natural disaster. But fortunately, these networks doesn't use a large amount of power, so they can operate for a significant period of time using low power. So these kind of technologies are well suited to do real-time monitoring, and they can be deployed depending on what you want to study or predict in near to rivers, as well as, for example, near to hilly areas to do landslide detection, earth movement, and so on. So these are some of the, I mean, since related to Ditwah, it was flooding and landslides. There are different sources of natural disasters as well, but I will keep my focus on these kind of issues. Also, if I want to talk a little bit on flood monitoring sensors, there are various type of sensors available in the market. So, for example, the one that you can see at the top of this slide is ultrasonic sensor developed by a university in the United States. So everywhere across the world, like say even at universities as well as at institutional levels, people are developing these kind of sensors. So because due to global warming, climate, and also due to climate change, these kind of natural disasters happen now more frequently than in the past. So anyway, like say, so there are ultrasonic level sensors. So they are non-contact, I mean, they can provide non-contact measurements, and they can be used in culverts, channel flows, as well as rivers to measure the water level. And there are pressure transducers. With pressure transducers, you have to make them submerge, and then depending on the pressure, the depth of water depth can be measured or estimated. And also, like say, the bottom figure shows radar level sensor. So basically, radar level sensors are ideal for harsh as well as turbulent conditions. They are unaffected by humidity because, I mean, we use electromagnetic waves in the case of radar sensors, as well as they are suitable for long-range measurements. Likewise, you have rain gauges as well as soil moisture sensors. So once you get the data out of these sensors, the next thing is like say to analyze this data and to predict the upcoming or imminent natural disaster. So now with the advancements of machine learning AI tools, we can do so effectively. So this becomes a very important area for us to pursue. So I hope some of you might get inspired by my presentation to deliver or to research more on these kind of topics. So in addition to that, we can also use cameras as smart sensors. Basically, I think most of the early cameras were just obtaining images or videos. But now we can even run some kind of machine learning algorithms in these kind of devices. So they come in very handy or useful to deploy these kind of applications. So basically, there are different types of cameras that you can use. The normal RGB cameras, Then you have thermal infrared cameras. For example, they are useful to detect humans as well as people who are under the rubble and clutter and so on due to, let's say, a flood and a flood kind of a situation. And also you can have wide angle or panoramic cameras that are capable of capturing a larger area coverage. And then, as I mentioned to you, the images as well as videos captured by these kind of smart cameras can be analyzed using AI-based technologies. For example, we can do object detection for people, vehicle, as well as damage infrastructure detection, and also to understand the severity of the disaster assessment and so on. So with this kind of sensors, there are a lot of issues as well. Say, for example, when you have occlusions, uh, let's say due to other people or due to debris or collapsed structures, these cameras might not be able to detect that, detect people in need and so on. And also, like say, sometimes due to rain, the lighting conditions might be poor, as well as in certain cases due to environmental factors that can arise in a natural disaster like smoke, fog, or mist. And the quality of the images acquired might be not so accurate to do image processing and so on. But however, these kind of technologies are very well popular these days, and a lot of interesting research happens in these type of fields. So basically, one thing that we need to do, if you want to think in terms of a pure communication point of view, we need to do frequency planning. Yes, frequency planning in the case of a disaster recovery or management situation, because sometimes we need additional bandwidth or additional services has to be provided for people. So we need to think of how to allocate more frequencies to cater these kind of actions or services. So wireless design should consider, because as you know, like say, wireless systems are based on electromagnetic wave propagation. So first of all, like say, we need to identify the propagation environment. So propagation environment in this kind of a situation depends on, for example, terrain dependent path loss or signal attenuation and shadowing due to debris and clutter. So these kind of things has to be modeled accurately. And then we need to calculate the link budgets for base stations to calculate the transmit power, as well as the antenna gains, as well as the receiver sensitivities. And then I think typically the performance of a communication system is based on SIN targets, or the SIN should be above a particular threshold value to enable reliable communications. So these things has to be planned properly by a telecom operator. And we also need to do cell optimization techniques. For example, where to put the base stations, because sometimes these base stations might not, they might got hit by these kind of events. Hit means like say they might be damaged or they might be out of service. So as a result, we need to place new base stations, and we need to decide or calculate where these kind of things has to be optimally placed. So we need to develop tools to do these kind of things, and also to calculate the optimal transmit power as antenna tilt to basically adjust the cell footprint, and also to limit the interference levels caused to other networks in the vicinity and so on. And fortunately, like say, some frequency bands have been already reserved or been assigned by ITU, International Telecommunications Union, for these kind of disaster relief operations. Say, for example, VHF, UHF bands are available to be used in this kind of disaster relief operations. So typically, there are different types of bands. So low frequency bands can be used to cover wider area, whereas high frequency bands with a high bandwidth can be used to provide broadband services, like say in the case of LTE and 5G based systems. And as I told you, the main challenge with frequency planning in the case of a disaster is the interference management along with the spectral management. So we need to have some kind of a dynamic frequency allocation method as well as priority access for emergency communications, unlike the case in the case of normal communications with in the case of there's no disaster. So these kind of things, I'm not so sure, like say what was the situation with during the Ditwah cyclone period. But for future, operators as well as various government institutions should look into this kind of aspects so that we can put a very strong framework in the case of future natural disasters. And so in the case of, redundancy is very important in the case of a natural disaster. So we need to provide multiple ways of communications using multiple channels like mobile, fiber optic, satellite, as well as public Wi-Fi, as I mentioned to you earlier, and also to provide resilience against total communication failure. So these kind of multiple channels of communications will help us to provide resilience, okay? Because, for example, I think even with Ditwah, it happened that some of the fiber optic cables were damaged. So in that case, if we had access to satellite services, if we had access to other wireless systems, some type of communication systems could have been restored pretty much earlier. So likewise, so redundancy in communication networks is an important factor to consider. And talking about satellite links, and these days I think all of us know about Starlink. So satellite communications earlier were confined to, let's say, geostationary satellite communications like broadcasting, television, and so on. But now with the development of these satellite swarms using nanosatellites, even for communication purposes, they are very useful for hard to reach, to provide telecommunication services in hard to reach remote areas, as well as in this kind of a disaster situation. It is very helpful. So we need to have some kind of a plan on how these services can be incorporated when they are required. So satellite links provide alternative connectivity when terrestrial links are failing, and also they extend mobile and internet services to isolated and disaster affected areas. So in addition to that, they are very helpful to provide different types of applications like disseminating alerts for telemedicine. Doctors can remotely monitor the situation of people, let's say, located in shelters or even in affected homes and so on, as well as in certain cases to coordinate the relief operations. So satellite networks has to be thought carefully in the case of future, when we are preparing for future disaster situations. So, I will not maybe discuss more about this Wi-Fi networks. So we can deploy these kind of Wi-Fi hotspots immediately in shelters, hospitals, schools for emergency use. And I think the utility or the service that they provide is very clear. Maybe I have also mentioned about them in some of the previous slides. So basically, this is a kind of attractive solution that we can think about deploying in the case of at least in future. So there are some issues as well. Not everything is perfect with these kind of technologies. So the coverage could be limited. And then basically the signal fading conditions, interference, as well as sometimes, let's say, if these kind of hotspots are deployed in shelters, if there are too many people trying to get connected to these systems, they can get clogged and the network can experience congestion issues and so on. Nevertheless, like say, I think we can do more research on the effectiveness of deploying these kind of Wi-Fi hotspots under these kind of challenging situations. So basically, and the other thing is, in addition to Wi-Fi, also there are deployable kind of emergency base station technologies. So different operators, sorry, not operators, some manufacturers of hardware have already developed these kind of devices. So basically, there are different types as well, aerial base stations, as well as some portable base stations. They are also called as cell on wheel systems. And also there are what you call tactical base stations where people can carry them as backpacks, especially helpful in the case of disaster recovery for disaster recovery teams. And also there are things called as high altitude platforms. So they are a little bit, I think, bigger than drones. And the altitude that their position is higher than drones, typical drones, so they can cover a wider area. So the mast of this kind of a device is extendable to a particular height, so that the coverage can be extended as required. So there are what you call the attractive features of or useful features of them are like say wide a lot. Basically, they enable rapid deployment as well as they can be autonomously or remotely managed from different locations. And also these things can be connected with satellite backhauls to provide even much broader coverage. Again, I'm not so sure about the operators, national operators in Sri Lanka, whether they use these kind of devices, but these technologies can be tested in case of in the future. So basically, not only deploying hardware, we can also think of like say asset management in the case of disasters, telecom asset management in this case. So basically, I mean, in terms of assets, you can talk about cell towers, base stations, fiber optic and microwave links, backup power systems, and all those kind of things. So basically, there are different ways of monitoring the condition of these assets during a disaster. IoT sensors for structural health and power status, and also drones and UAVs or UAVs can be used for aerial inspections. And the role of AI in this kind of asset monitoring situation is applications is high. So for example, I mean, AI can be used to analyze the sensor or the drone data to detect anomalies or damages automatically. And also, for example, they can predict potential failures in terms of assets. And they can, for example, they can measure the currents, voltages, and based on those kind of profiles, they can predict whether these devices will last maybe for 1 hour or 6 hours or 2-3 days and so on. And also, basically, they can classify the damage severity using computer vision. So basically, asset management is very important. And in addition to asset management, like say, these kind of methods can be deployed so that they are managed more effectively. So basically, and in the case of natural disasters, we also talk of we use the word resilience more often. So basically, now this telecom equipment has to be made resilient, as well as shelters has to be designed. I have another slide related to shelter design a little bit later. So basically, reinforced telecom towers, shelters to withstand high winds and so on in the case of hurricanes. And also, they provide indoor communication services using technologies such as visible light communication systems. Okay, and they are also we need to deploy flood-proof fiber telecom asset deployments because I think even in the case of Ditwah, there were a lot of fiber damages reported. So basically, there should be some kind of procedures adopted to make sure that the deployment of fiber is resilient. And also, basically, we shouldn't install these kind of devices where landslides are frequent to happen. So there are a lot of aspects that need to cover when it comes to infrastructure, telecom infrastructure. So this is related to fiber something. So we need to physically protect it. So, for example, armored elevated cables, protective ducts, as well as flood-resistant installations has to be used. And also, there should be some kind of redundancy. So, for example, if you talk of fiber, we can deploy them in ring configuration in mesh topologies. So, if there is a damage to one fiber part, other fiber undamaged parts can still carry on telecommunication traffic and so on. And as I told you, these things has to be laid in areas where to avoid landslides as well as erosion-prone soil has to be, I think, avoided as much as possible when these things are laid in the first place. So there are a lot of things related to fiber because the core networks are based on fiber. Access networks are based on wireless connections. So there are a lot of things that we need to now think carefully when it comes to fiber network deployment. So this is the slide on shelters. So basically, I think again, these kind of shelters for base station housing as well as other equipments, there are a lot of products related to these kind of shelters. So they enable rapid deployment of temporary base stations and also provides protected environment for telecom equipment to function. So, there are several design characteristics of them. They have to be windproof, they have to be waterproof and dustproof and so on. So typically they have a modular design structure, easy to transport, install as well as to expand if you want to provide higher capacities for different areas. And also they are typically integrated systems. So that means you have a cabin and the power, AC, monitoring equipment, all housed in different compartments of this cabin. So there are a lot of evolution trends. That means like say, in terms of designing these kind of shelters, so basically what I have found is that say they are looking for integrated container shelters. So pre-installed equipment, generators, antenna poles, everything connected together. And also, the reduced deployment time is an important consideration. For example, on-site wiring time should be minimal. Configuration has to be simpler so that even untrained people, in the case of a disaster, can easily deploy them. And also, like say, since these base stations require a lot of energy to function, and especially in the case of natural disasters, energy is limited. Access to, let's say, stable energy is limited. Basically, you need to install them with, for example, energy sources as well as to do thermal optimization so that these systems can function without, breaking in a disaster situation. So, and then in terms of supplying energy to telecom services, it's a significant thing. Basically, I think as we experience, the mains electricity supply can, may not function during a disaster. So you can go for alternative sources like solar panels, batteries, as well as microgrids. So basically, as I mentioned, cyclone during the Ditwah period, power outages and were common due to infrastructure damage, and that caused major power disruptions. So there are a lot of, when I searched the internet, there were a lot of global good practices happening in different countries. Like in Philippines, they are deploying hybrid microgrids for supplying power to base stations. In Japan, battery and renewable power. And in South America, basically, they might have also experienced a lot of earthquakes in a particular time. So that also, I think, highlighted the need for backup systems and so on. And in addition to this, alternative power sources, AI can also be used to optimize the power usage as well as to predict the energy demands of these kind of base stations to optimize the performance. So basically, I will maybe skip because due to the limited amount of time. So we need to coordinate all these kind of emergency services so that everything will function smoothly during this kind of a very challenging situation. So telecom networks enable seamless communication between different institutions like hospitals, fire services, as well as police and the military. So for all of them to work efficiently, the network has to be, it has to perform up to a good level. So this coordination is an important factor in terms of telecommunication in a natural disaster. So then also, like say, there are, I think, common, alerting protocol. There's a common alerting protocol called CAP, I think developed by ITU. So basically, if I'm not mistaken, so this protocol enables authorities to issue disaster alerts, as well as, for example, in many different ways. So according to the protocol, basically information can be forwarded in terms of XML formats, machine readable as well as human readable, as well as, so as a result, it includes text as well as geographic data like circles, geocodes, polygons, and so on. So applications can read the information coming through this protocol to provide different services. So as I mentioned, like say, this protocol enables multi-channel dissemination, mobile phones, internet, as well as satellites, as well as even in billboards, digital signage. This information coming through this protocol can be displayed. So basically, I wanted to introduce you this protocol. It is called as Common Alerting Protocol because it seems to be a universal protocol adapted in the case of disaster recovery situations. Because maybe our systems can be equipped with these kind of protocols in future. So this one I will skip. Basically, the information, the public has to be guided as well as they have to be informed. So for those things, we need digital platforms. I think I mentioned about these kind of services at the beginning. So I will skip this slide. And now I will talk a little bit on the role of AI. In the remaining time, a little bit on the role of AI for disaster management situations. So this includes optimization of telecom infrastructure as well as to deploy new services, and that will be useful for citizens as well as government authorities and so on. So AI enables real-time network monitoring to detect faults as well as congestions during outage periods. And also, more importantly, AI enables predictive maintenance, allows forecasting infrastructure failures, minimizing downtime. Because with the data, AI can be trained to figure out, right, whether there are any failure modes in future, failure modes in future. So these things will be kind of helpful to understand the performance of our network into future. And also, as we discussed in the case of a disaster, telecommunication networks will undergo a lot of dynamic scenarios, like to allocate bandwidth, allocate power, to control the interference and so on. So these kind of resource allocation tasks can be optimized using AI. So there are a lot of, kind of widespread users of AI well suited to, for these kind of situations. So basically, in the case of early warning systems, AI algorithms can analyze prior weather conditions, hydrological conditions, as well as geospatial data, and then to predict any hazard to predict the hazard intensity as well as whether there will be a disaster in the imminent future, and so all those kind of things can be performed using AI algorithms. Okay, and also basically it reduces kind of false alarms, because the more the data AI has, the training becomes accurate. So this will also help to improve the public trust in AI algorithms. And also, like say, when this information is disseminated, people will find it useful. So real-time risk assessment and resource allocation during evolving disaster events. So I think we discussed about them in some of the earlier slides. So basically for decision making, right? So once you have the early warning information, and then during the decision making and the response, also AI is helpful. So basically, in case of, analyzes real-time sensor data to support rapid evidence-based decision making. So based on the information coming from the sensors, AI can decide, right, where to allocate, like say, for example, in the case of dispatching, let's say, rescue teams, how many number of people has to be allocated to which location, and all those kind of things. AI can decide in addition to humans in a much more rapid manner. So optimize, that's as a result, we can optimize the allocation of emergency resources and so on. There are also, you can design AI-powered applications, platforms to enable for citizens to report hazards. Say, for example, currently I'm working on this kind of research at University of Peradeniya. So we are developing a system where normal people can, say, for example, take photos in different locations where they think that there are, for example, a mini landslide or some kind of a water condition, water rising condition, and so on. So this kind of information can be fed to some AI algorithms to assess the damage, as well as to dispatch, as I told you, rescue teams in future. So there are a lot of widespread kind of applications, but due to limited time, I will go on to other topics. And search and rescue using drones is an important thing. This image shows it's not a fake image, it's a real image. So basically what has happened is, like say, a drone has been used for to carry, to rescue a human. So this it says that, say, this drone can carry about 200 kilograms. So definitely it can carry a normal size human. These drones can be equipped with AI technology to detect humans even in submerged conditions. So then they can be located, or they can be moved onto these positions with the correct equipment for the human to get rescued. So there are a lot of interesting applications in case of search and rescue drones. And also, in some cases, these drones can be deployed as a backbone or an alternative communication link from, let's say, from the affected area to the core network. And then in this case, the drones will act like relays. So there are a lot of interesting applications related to search and rescue drones. Then in terms of damage assessment, this is basically drones or any imagery can be used. For example, satellite imagery can also be used to assess the damage. So this kind of damage assessment helps to prioritize repairs. Okay, there are a lot of use cases, basically to roads, bridges, powers, as well as water systems. And then the damage assessment will be really helpful for various institutions like the police, as well as to rescue teams and all those kind of different groups to rescue people, as well as to restore services in the case of critical services and so on. So in case of, things that you typically come up with damage assessment, that means computer vision based damage assessment. Basically, there are different tasks we do: object detection, image classification, image segmentation, change detection, as well as object tracking. So if with object detection, so if you take this kind of image, you can, for example, identify whether there are houses, there are submerged areas, and so on. And then if I give you this kind of image, it can classify whether this is a flood scenario or this is a normal scenario, and so on. And then with segmentation, I think the bottom figure is an example of segmentations where Like say these flooded areas have been marked in dark blue color, and the houses have been marked in red color, and so on. So there are a lot of machine learning tasks that we can do in when it comes to damage assessment, and then in case of these kind of applications. And also there are two very important as well as interesting applications. One is visual question answering, VQA. So we can give this image to a AI, let's say algorithm or something, and ask, do you see a flooding situation? How many houses have been damaged? Do you see any people in trouble, and so on? So the algorithm will answer these questions, and then the output of these, the questions can be given to relevant people to act after that. Even, in the case of rescue drones, the algorithm can even issue commands for a drone to provide these kind of rescue services. So likewise in the machine learning world, there are a lot of things like that we do, like say we can also use in order to train these kind of applications. We can use generative AI, as well as in some cases we can do 3D reconstruction to accurately understand the situation, and so on. Due to limited time, I will not go into details. This is actually one of the research works that I did along with some of my students. So basically the research paper is mentioned at the bottom of this slide. So here what we did was we considered a drone-based disaster recovery situation where the drone acquires images on the ground, and then based on the images, the drone has to do several tasks. Say, for example, damage classification, as well as visual question answering, as I explained to you. So the one problem with the drone is that, say, as all of you know, the drones do not have a lot of power. So you cannot run a lot of like high power or sophisticated machine learning algorithms typically in a drone. So basically we need to use something called tiny machine learning algorithms to, for example, in these kind of drones, to effectively do these kind of tasks. So in this research work, what we did was based on the acquired images, our drone was, not the drone, but the machine learning algorithm was capable of doing multiple tasks, because in previous papers, most of the time they have been programmed only to do damage classification, or let's say to do VQA, or to, let's say, to do object detection. The good thing about our approach is that, say, using like say the algorithm, like our algorithm is capable of doing multiple tasks. So basically it was interesting. And also like say we also considered communication constraints because when we want to downlink these kind of images into a bandwidth limited a network, in the case of a disaster recovery system, there will be a lot of delays. So in order to minimize the delays, what we did was, like say, we only took a mask out of this image. That means, let's say, partial information out of this image, so that the latencies associated with data transmission was minimized, while we were able to get a high accuracy for damage assessment, as well as visual question answering tasks. So this is just for you to get a basic idea of what kind of research as well as technologies can be deployed in the case of future disasters. So the data set that we actually used was something that was available in the internet, but I hope that we can also take data related to Sri Lankan context. So since now we have a lot of information or images related to Ditwah, we plan to train our models using those images as well. So anyway, that's about the work. So I'll skip these slides about the work. And then, like I said, now I will come into the last part of my presentation. So there are some key takeaways that we can take out of this Ditwah catastrophe. So basically, as we all know, telecommunication outages disrupt emergency alerts and delayed public warnings. And this clearly highlighted the network vulnerabilities in the case of in Sri Lankan context. In some cases, backup power systems as well as satellite links help to maintain partial connectivity. Basically, now these are some of the things that we learn, but one thing that we can gather is that, say, AI as well as predictive analytics that I mentioned to you during the presentation can enhance the early warning systems significantly. So we should push a lot of research on this type of field. And also it emphasizes the need for some kind of an integrated multi-channel communication network approach for effective disaster response. Okay. So basically, we need to, I think, maintain some kind of a database related to telecom and ICT in the case to be used in emergency. So this database has to be maintained continuously, not only in, for example, in the case of a disaster, but this has to be done continuously. So it is essential for risk management, vulnerability assessments, and all those kind of things. So this could be done in a national level rather than, of course, individual operators can also do their own databases, but I think a national database will also be very helpful. So some of the key information that we can include will be available telecommunications as well as ICT services, terrestrial coverage areas, as well as infrastructure locations, tower locations, power station locations, and as well as different network type locations, as well as, if you have pre-position equipment locations, pre-position equipment, we can do, maintain the locations of this kind of equipment, and as well as, some kind of a understanding about the vulnerability of this kind of infrastructure, whether they are medium or low or high risk and so on. So as I told you, this kind of database should be deployed or developed collaboratively among government, telecom operators, broadcasters, amateur radio organizers, and organizations, and so on. And one thing is that, say, since this will carry a lot of sensitive data, because this also includes the vulnerabilities of each of the operators' networks. So I think the confidentiality of information will be very vital or critical in maintaining this kind of, when you maintain the database, as well as they should be only strictly used for emergency as well as disaster management purposes, not for any other reason, because this includes a lot of sensitive information related to the country situation among the network operators. But I hope this kind of thing will be useful. So another thing is that, say, also we need to conduct training drills as well as community engagement, because I think most of the time we are reactive than proactive as a nation. So basically, time to time, kind of regular exercises should happen in terms of even telecom providers, emergency responders, as well as local authorities, as well as educate school children, as well as like any person, and so on. And also there should be some kind of recognition for telecommunication networks as critical national infrastructure. And as a result, we can think of expanding these kind of networks together with technology that we discussed, as well as to make them disaster resilient, along with backup power systems and so on. And AI as well as machine learning algorithms can be used to enhance the performance of these kind of networks, especially for early warning systems, real-time monitoring, as well as emergency planning. And I think I'm coming to the last kind of slides with the presentation. So I just wanted to introduce you this thing called the Tampere Convention. Basically, Tampere is a city in Finland. So basically now this convention, I think, is managed by ITU, International Telecommunications Union. So it has been adopted in 1998, and then it has come into force in 2005. So the objective of this convention is to facilitate the rapid deployment of telecommunications resources for disaster relief. So it says signatory states, that means countries, allow swift means a rapid deployment of emergency telecom equipment and personnel. And also this convention helps us to remove bureaucratic as well as regulatory obstacles during disaster response. And it says encourage international cooperation and resource sharing for disaster mitigation. So when I checked into the current status of this convention, there are 50 countries who have signed the convention. And then among them, Sri Lanka is also one country. So it's very interesting because with this convention, there are a lot of important things that I think we can do. Say, for example, under the implications of disaster communication, it says, I mean, you can also go and download this document. It's available in 3 languages, English, French, and another language. Basically, I downloaded a copy of this convention. So basically, it supports emergency frequency allocation and coordination, as well as, for example, facilitates international aid, as well as rapid network deployment. And also, it defines some kind of a legal framework. Say, for example, during this kind of a disaster, we can use hardware without licensing agreements and so on. I mean, if the other country who has manufactured the telecom equipment is also a signatory of this kind of convention. So it is very interesting. I don't know like how much of useful, I mean, whether we have used this convention during the Ditwah cyclone period, but at least in the future, like say, we can maybe look into the convention, and if there are useful features, we can definitely adopt in case of future disasters. So that's why I wanted to let you know. So there are a lot of future opportunities, like with predictive AI for multi-hazard risk management. And we can integrate this kind of technologies with smart city infrastructure, because even in Sri Lanka now, we talk about smart cities. So definitely one aspect of smart cities to include these kind of IoT sensors, vision cameras, as well as these kind of coordinated telecom networks. So this can be done, as well as a real-time coordination of, let's say, dashboard. So that means different agencies, institutions can look into data with each other to do much more effective kind of search and rescue operations, as well as to deploy hardware in much more efficient manner. So just to, this is my final slide. So to summarize, today what I presented was about telecommunication systems as critical as for disaster preparedness, as well as to response. So telecommunication systems play a vital role in this task. And the second thing I wanted to highlight was AI has a big potential to improve disaster management by enhancing early warning, supporting informed decision making, as well as accelerating these recovery efforts. And then I think with the recent developments, Cyclone Ditwah highlighted the urgent need for resilient telecommunication infrastructure and cutting-edge AI approaches to be deployed in the case of disaster response. So with that, I will conclude my presentation. Sorry for going a little bit overboard. And I hope to answer any of your questions if you have them now. Thank you very much.
Thank you very much, sir. I think we would like to express our sincere appreciation, actually, because we know that you are, I mean, not feeling well. Despite that, I mean, you delivered a really insightful lecture. And I think most of you are aware that Dr. Himal Suraweera is actually has been recognized among the top 2% of researchers worldwide based on the H index, I think based on their citation impact, based on their publications. So he's among the top 2% of researchers worldwide. And I personally know that a lot of students, a lot of people got opportunities in Finland because of his work. And so we actually would like to thank Dr. Himal Suraweera for this insightful session. So let's move on to the Q&A session. So there is actually one, I think, from Mr. Pasindu Pereira. So I will read the question. Many of the base stations were backhauled by fiber and wireless transmission links because those were removed considered legacy system removal, causing failures of sites. There is a need of an unified network dedicated for emergency transmission with all service providers with multiple redundancy plans. I think kind of a suggestion. Anything to add, sir?
Yeah, I think Deshante, that's very correct. I think even during the presentation, I think I highlighted some of those aspects. So basically, I think if you take a telecommunication network, there are basically two parts. One is the access network and the backhaul network or the core network. So core network is based on optics, fiber optics, at least at the moment. And then the access part is based on wireless technology. So as Mr. Pasindu mentioned, like say basically maybe when telecom operators were upgrading to 5G systems or 4G systems, maybe some of those fiber were removed. But I think they must have been, getting reinstalled. And then these kind of networks has to be coordinated, I think, among different operators. So I think this the convention as well as certain regulatory provisions has to be provided by TRCSL so that in the case of disasters, we could share the networks among different operators as well as also to lay out these kind of redundant network paths so that if one path gets affected by a landslide or any other disaster, something really like that, so that other redundant paths can be utilized to provide network traffic and so on. So, basically, and also like say another aspect is to, I think he also mentioned like say to consider satellite links because I think, unfortunately Sri Lanka has not I think satellites of own. Now Starlink as well as other kind of, there could be other type of systems where their services can be at least leased during these kind of disaster recovery situations. So all those kind of things has to be integrated. Multi-channel means that, as well as among the different operators, there should be a strong coordination. So I totally agree. And then I think ITU as well as these kind of, even at government level, there are some initiatives. I'm not so aware of in Sri Lanka, but in other countries like in Japan, USA, as well as Europe. So maybe those practices should also be looked into and adopted in the case of Sri Lankan context.
Okay, sir. Thank you very much. So there's another question from Mr. Mohan. So I will read that as well. During the Ditwah disaster, we come across a complete failure of various telecom facility providers. So affected party unable to communicate any alert messages to escape from their dwellings. So if there are any possibility of providing communication by public Wi-Fi freely available with proper infrastructure, not affected by natural disaster.
Again, I think I discuss about
Yeah,
this.
yeah.
So yes, so I think basically what we need to do now is to understand the need for these kind of things or technologies, and to install them so that I think it's not nice to say, but there will be some kind of a disaster happening in future. So at least in that time, these kind of things has to be deployed. So what he's saying is correct. So all these kind of things has to be tested out before a disaster, and definitely they has to be deployed. So even inside shelters, I think, for example, now earlier, like say, people just used to go there and then stay there. But now with the advancement of technologies, like say, we can provide medical services as well as we can provide some kind of communication services for these people to carry on with the harsh situation and so on. So to provide these kind of services, these public Wi-Fi Wi-Fi spots, all those kind of things are useful. So I hope that maybe during this year, during the remaining time here, and then maybe next year, there will be some kind of a national initiative. So actually last 1 month ago, Also, we did some kind of session, myself and Dr. Bindu were from my department, and there were a lot of kind of similar sessions as well. Like say, so during that one, each topic was catering a particular aspect related to disaster management. So, and then it was like say targeted as a national initiative. I think the reason is that. So I hope, like say, with this kind of important discussions that you are stirring up, somebody will take attention, and then based on that, relevant actions will, come into play soon.
Sure, sir. I think the academics and also the industrial expertise should join together and initiate these things. So yes, got the idea.
Yeah, that's correct. So, Dushyant, and the other thing is, I think in the case of, I think I have heard in Japan as well as I have some colleagues over there. So, I think they have a pretty solid kind of, groundwork as well as a network laid down in Japan. I'm not telling Japan is the only country. There could be many other countries as well. So we can take a lot of lessons from their experience as well as how they are maintaining as well as operating the network. I think these kind of things will be useful. So one more thing that I didn't highlight is that say now there's this phenomenon called flash flooding. So basically during a very short interval of time, like say there'll be a lot of water poured down. So as a result, like say some area, especially urban area, can really get flooded very fast. So maybe that water will recede fast as well, but at least during 1 or 2 days, that one particular area will be severely affected. So even in the case of flash flooding, I have seen some operators in other countries coming up with various solutions to handle those kind of situations. So in one way, it's very interesting because these kind of situations make people to come up with innovative solutions.
Sure, sir. Thank you very much. There are no any other questions in the chat box. If you have any questions, you can raise your hand and talk. We can unmute you. Since there are no any other questions, so we can move on to our next item. So I would like to invite Engineer Dilina Charnaka to deliver the vote of thanks. Dilina, it's up to you.
Thank you, Dushyant. Good evening, everyone. As we come to the end of this insightful webinar, it is my pleasure to deliver the vote of thanks. First and foremost, I would like to express our sincere gratitude to our distinguished resource person, Dr. Himal Suraweera, for sharing his valuable knowledge and expertise on telecommunication as critical infrastructures for disaster management. Your presentation has given us important insight into the role of communication systems in disaster resilience, early warning, and recovery. We truly appreciate the time and effort you have taken to be with us today, despite being not in good health. Wish you a speed recovery as well. Also, I would like to extend our sincere appreciation to the President of the Institution of Engineers Sri Lanka, Engineer Kosala Kamrudeniya, for his continued encouragement and support for knowledge sharing initiatives within this engineering community. My appreciation is also due to the Chairman of Electrical, Electronic and Telecommunication Engineering Sectional Committee, Engineer Viraj Muthugala, for his leadership and guidance in organizing such valuable technical sessions. I would also like to thank dedicated organizing team of EETSC and the IESL Secretariat for their hard work and commitment in successfully arranging this webinar. Finally, my sincere thanks go to all the participants who joined us today. Your presence, interest, and engagement are what makes events like this truly meaningful. With that, I conclude the vote of thanks. Thank you all and have a pleasant evening.
Thank you. Thank you very much, Engineer Dilina Charnaka. So we'll actually conclude the session. I would like to express my gratitude again to Dr. Himal Suraweera. Thank you, sir. So let's meet from another session, which will be organized by Electrical Electronic Telecommunications Sectional Committee. Thank you again. Good night to all.